Hello, welcome back to the second part of week 6 of the ECE 9013 course. In this part, we are going to further discuss the difference between recursion and iteration and provide some further illustrative examples. So, going back to the factorial example. To do the factorial calculation using an iterative manner, we need to first define a variable which will hold the product or the end result, initiate it to 1, and then iterate for all the values in the range from 1 to n. That's why we set here n as the ending condition as n plus 1, so that we actually include the value of n. And we always multiply the value within prod by the value of the index I, and we finally return prod. However, as shown earlier, we can actually define it in a factorial manner. So, although iteratively it might be more intuitive to calculate and maybe simpler for a programmer to develop, it is more computationally efficient to calculate the factorial using the recursion method, because we don't have to go through the for loop. Also, it becomes much easier to debug when defining the factorial in a recursive manner. Here we give another example of how we use recursion to calculate a Fibonacci series. So by definition, a Fibonacci series starts with the values 1 for the first two values, and then starting from k equal to 2, it's equal to the sum of the previous two values. So using this definition, the Fibonacci series is as follows. It's 1, 1, 2, 3, 5, 8, 13, 21, and so on. Now, to calculate a Fibonacci series, we can do it in an iterative manner or a recursive manner. So starting off with the recursive manner, we start with the base cases, which is if k equal to 0 or k equal to 1, we should return 1. And the recursive step is returning the output of the previous two values. So in this case, we define Fibonacci as if x is equal to 0 or x equal to 1, we return 1. Else, we return the sum of the Fibonacci of x minus 1 plus Fibonacci of x minus 2. And then we can try printing the fib of 4, which is the fourth item. Another example is the palindrome string example. So by definition, a palindrome string is a sequence of characters which reads the same in both directions. As an example, this string, was it a car or a cat I saw? If we read it from the reverse direction, it would still read, was it a car or a cat I saw? Similarly here, we can read it as no X in Nixon and no X in Nixon. So to determine whether a string is a palindrome or not, we first need to remove spaces, commas, or any characters that are not in the alphabet. We can make sure that all the string is in lowercase format, and now we can check the string for whether it's a palindrome. So that's why here we first transform all the characters to lower. And then we can do it in an iterative manner to check and remove all of the characters that are not alphabet. And this is why this function is called toChars, because it transforms the string to only alphabet characters. Now the iterative solution, we always check if the index at I is the same as the character at index length minus 1 minus I. If it is, we return 0, else we return 1. So if any character is different, we return 1. If all of the characters are the same, we will return 0. However, this can be done in a recursive manner. So the base case is if the string is empty or if the length is 1. And the recursive step is checking always string at 0 and string minus 1, which is the first character and last character, and then slice the string to shorten it and create a new slice, which is the reduced string. Implementing this would give us a true, and you can check it out by running the actual code. So as we mentioned, that the recursive functions are an example of a divide and conquer algorithm. They are used to solve a hard problem by breaking it into a set of sub-problems such that the sub-problems are easier to solve than the original, and the solutions of the sub-problems can be combined to solve the original problem. Thank you.